I'm recording this again. Anyway, let's try. So, we're going to discuss polymerization. Polymerization. And polymerization basically means forming long chains from monomers, right? And monomers combine many monomers together, you get polymers, right? There are two types of polymerization. There's addition, and then there's condensation. Okay. Let's discuss addition first. Addition, remember what kind of substances undergo addition reactions? These are double bonds. I'll repeat. What kind of substances undergo addition reactions? These are double bonds. So when we're in the context of addition reactions, we're talking about items having double bonds, right? So this is the monomer. This is the monomer. And it joins to another similar monomer, right? So these are monomers, and of course you have lots and lots of them going that way. And so basically, when you join monomers together, the double bond opens up so that where you had a double bond, you've got single bonds, right? So now I've formed a polymer by joining many double bond items together. Does it make sense? Like that. So it'll look something similar to that, right? And then it continues forever. Well, not forever, up to a point, but you get what I'm trying to say, right? So where there was a double bond, the double bond opened up, and so that they could join together and form monomers with single bonds. This is what we call addition polymerization. So only items with double bonds undergo addition reactions, hence addition polymerization. I hope that makes perfect sense to you. Right, now, say for example, you had to do... So the interesting thing about this is that as you can see in the example above, I've drawn 3 repeat units. I've drawn how many? 3 repeat units. But of course, generally speaking, you don't want to draw 3 repeat units. You want to draw 1, unless the examiner says he wants 3. If he doesn't say he wants 3, draw only 1. So what you do is kind of like, Superman and Clark Kent. Clark Kent was Superman, but the only difference is that he would take off his glasses. When he wore his glasses, he was Clark Kent. When he took off his glasses, he was Superman. And for some reason, nobody recognized him. This is the weird and wacky world of Superman. But anyway, I hope this makes sense. Well, not wacky, just interesting and strange. Anyway, you get what I'm trying to say? So in this case, what I have here is a monomer. What I have here is a monomer. See? Monomer. Double bond. Then, look at the transformation. I remove the double bond, and what I now have is a polymer. So from monomer, we now have polymer. I'm going to put an N to show that it now is a chain. It's now a chain. So do you get how easy this is? Put the double bond back, and put the double bond back, and we are back at being a monomer, right? Remove double bond, and we have a polymer. Okay, I hope that makes sense. So say, for example, you have to form the polymer of butene. Remember, it has to be an alkene to have addition reactions. Okay, so butene. So butene, I always say to the kids, draw it in a sort of L shape. Draw it in a sort of L shape. So you've got H. So bute has 4 carbons. So the other, I've got 2 so far, right, with a double bond, of course. I've got 2 so far with a double bond, but now the other 2 can be on the side. They don't need to be in the H shape. Do you see what I mean by the H shape? This H part of it so generally set it up in the H, so if there's anything extra, it can come down here. The extra carbons can come down or up, wherever, but not in the main H of the shape. And here, of course, I still have a double bond, right? And of course, like we've learned, we want to turn that. So this is still a monomer. This is still a what? A monomer. And we want to turn that into a polymer. So what happens? We erase that and put square brackets with an N, remove the double bond. Now it's a monomer. Now it's a polymer, sorry. Monomer turns to polymer when you do this. So show that it continues. So this shows that it has become a long chain and it is continuous. Okay? And that it continues, that there are many of them. All right? So always sort of put it into an H shape so that you can do this with ease in the sort of H shape, always. And work with an H shape for addition polymerization. All right. Now let's get into condensation polymerization. There are two types of condensation polymers. Well, let's discuss the first one. You'll notice, what is this? You try and tell me what this is. The box just means don't worry about what's inside. The box just means don't worry about what's inside. So what you have here, are you thinking? Do I recognize this functional group? That is the acid functional group. So this is a diacid. It's a diacid, dicarboxylic acid. And then dicarboxylic acid. What's this? Who is this? Do you recognize this functional group? Do you recognize this functional group? That is an alcohol, so it's a diol. It's a dialcohol. It's a what? A diol or a dialcohol, right? So let's remember, where do I always break the acid? Where do I always break the acid? I break the acid at the OH, don't I? Where do I always break the alcohol? Alcohol is broken at the H, just the H. And you join them together forever. Join them together. And what you now have, this is now an ester, isn't it? Cool. Remember this? The ester linkage. The ester linkage cool. And of course, I'm going to show it continues. Where do I always continue the alcohol? The alcohol I continue from the... Where would I continue an alcohol? Alcohol always break the H. From alcohol, you break the H, right? Break the H. And from an acid, where do I break the acid? Where do I break the acid? I break the acid at the OH. Remember that? At the OH. So, and then you just draw a little line like that to show that it can put an N to show it continues. All right. So this is what we call a polyester. Polyester. Remember, polyester comes from the great love affair of alcohol and acid. But of course, to make a polyester, to make a long chain, everyone should have two hands, right? It should be a diacid and a dialcohol. Do you get the point? So, for example, if I want to make a long human chain, everybody should have two hands. You agree? Everyone should have two hands. If I have disabled young people who have one hand, that might not work to make a human chain, isn't it? So everyone should have two hands to make a long chain. Two hands to make a long chain. I hope you get the point. So to make a polyester, which is a long chain, I need not just an acid, I need a diacid and a dialcohol, two-handed alcohol, two-handed acid, do you get it? And then they can join together to make a long chain called a polyester. An example for polyester is tyrrolene. It's what? Tyrrolene. And it is used for clothes. This is an example of a polyester. Tyrrolene used for clothes. I hope that makes sense. Now, look at this. Can you tell me what this is? Let's see if you can tell. What is that? Diacid, correct. Why do I need a two-handed acid? Because I want to make a long chain again. You see, I make a long chain. And long chains only work when everyone has two hands. Do you get what I'm trying to say? All right, so that's a diacid. And who is this? It's nitrogen. Who's this? Notice nitrogen makes 3 bonds, because in group 5, obvious. Struggling to draw this here. Right. Is it better or worse? Really hard. All right. Do you get the point? So I need a diacid, dicarboxylic acid, right? And the it's called an amine. It's a diamine too. So this functional group is called the amine. Functional group is called the amine. We haven't talked about it before, but you probably should know this by now at this stage in your lives. So you've got a dicarboxylic acid and a diamine. Why do they need to be di? Why do they need two hands to be di? So that they can form long chains, all right? Now, from the acid, I break the OH as usual. From the amine, I break the H, and then I join them together. Together. Join together, and this time you form what is called the amide. From an amine, you make an amide linkage. All right, amide linkage. All right, NHCO, 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 instead of COO, COO, NHCO this time. You make what? NHCO, and I hope that makes sense. And of course, you need to show how it continues. Where would I break this to continue it? I break from the acid side. I break the OH, of course, not hard. Close the bracket, and from the amine side, I break the H. From the amine side, I break the H. Struggling to erase this. Okay, there we go. Break the H, and then close the bracket. Okay. All right, not closing well. There we go. You see, close the bracket. All right, I hope that makes sense. Put an N. All right, I hope that makes sense. So this is a dicarboxylic acid or diamine, and you put the amide linkage. So it's called a polyamide. It's called a poly what? Amide, because of the NHCO for the amide linkage, but polyamide. Examples are nylon, and used for making rope. Used for making rope. Okay, so just important to remember. Examples, nylon, used for rope. Right, and then very quickly, let's discuss isomerism. So, in an isomer, so for example, if I gave you like this, I gave you 1, 2, 3 with an OH, right? So I always suggest if you want to change the isomer, just move the functional group. Move the what? Functional group. This is on carbon number 1. This is carbon number 2, carbon number 3. Or alternatively, this could become carbon 1, 2, and 3, depending on which direction you count. You always count in the direction that gives you the smallest number. So this is a type of alcohol. This is propan 1-ol, right? So carbon number 1. So if I was to change this and move this to here, the OH here, have I made an isomer here? No. Have I made an isomer? Certainly not. Why is it not an isomer? Because it's still on carbon number 1, you see? So moving it from here to here has not formed another isomer, you see? It has to be in a different carbon number. So maybe the correct way of doing it would be to put the OH here. Do you see that? Put the OH in this position here and have an H, and then now it's on carbon number 2. So from propan 1-ol, this one, I now have propan 2-ol. Propan 2-ol. Okay. I hope that makes perfect sense, yeah? So for propan 1-ol, I now have propan 2-ol. I fear I've been writing upside down. Well, let's see what it looks like. So propan 1-ol, carbon number 1, propan 2-ol. So these are isomers. So what is isomerism? They have the same. What is isomerism? They have the same molecular formula. What do I mean by saying molecular formula? For example, this would have been how many carbons? 1, 2, 3 carbons. How many hydrogens? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens and 1 oxygen, right? This is the molecular formula for both of them. But the structural formula is different. You see, the drawn formula is different when you draw them. So they have the same molecular formula, but different structural. The formula you draw out, like with the lines like this, it's called the structural. So different structural or displayed formula, different structural displayed formula. All right. They have the same molecular formula but different structural or displayed formula. That is what we mean by isomerism. And another example is maybe the double bond. Let's say, for example, we have 1, 2, 3, 4. Right? You see this? Each carbon must have 4, right? So I'm just checking. Yeah, each carbon has 4. So again, this is but 1-ene on carbon number 1. The double bond is on carbon number 1. And moving this double bond here is not made any isomerisms, you see? They've not made a different isomer because it's still on carbon number 1. Do you see what I mean? It's still on carbon number 1. So this is not an isomer. Not an isomer. You appreciate that? This is still but1-ene. So if I wanted to make a different isomer, where I need to put the double bond is maybe somewhere here. Then turn that into an H. And then this is now but2-ene. All right, I hope that makes sense. And then making alcohol. So remember we discussed ene to all makes alcohol, 300 degrees Celsius, 60 atmospheres, phosphoric acid for catalyst, Then all to acid by oxidation. Remember that? All to acid by oxidation using potassium manganate 7. Remember? Acidified. And then we said between all and acid is the famous love affair between the alcohol and the acid under the bridge. They make baby ester, remember? Now, the other way of making an alcohol, instead of saying ene to all, is fermentation. With fermentation, you need yeast as a catalyst. Yeast have the enzymes that catalyze the reaction. Yeast has the enzymes that catalyze the reaction. And what's happening is what we call anaerobic respiration, which basically means that it's in the absence of oxygen. So anaerobic respiration occurs. It's respiration in the absence of oxygen. It's respiration in the absence of oxygen. So anaerobic respiration is what's happening in the process. So anaerobic respiration in the absence of oxygen. What else can I say about this? Give me a second, someone's at the door. So the reaction, glucose C6H12O6 produces ethanol C2H5OH, so it produces ethanol and carbon dioxide. So glucose to ethanol and carbon dioxide. So conditions: 1 must be in the absence of oxygen. That's one condition. Second condition requires enzymes with yeast. Yeast with enzymes requires enzymes with yeast. And I think there's maybe some might say temperature. The temperature range is very limited, maybe like just between 25 degrees Celsius, if I remember correctly, and 30 degrees. So it's a very small temperature range, okay? So one could argue, what is the advantages of fermentation over ethanol? The advantages of ethanol, using ethanol, I mean, not ethanol. Advantages of fermentation. The advantages of fermentations are: one, it is a simple method, not complex. There's a simple method, whereas the other one is very complex, requiring 300 degrees Celsius, requiring a catalyst. This one is a simple method. Another advantage, maybe you could say it uses a renewable resource. Right? We can always get yeast and glucose and all of that uses renewable resources. But of course, the disadvantage is it's quite slow. It's quite slow compared to the other one. And it needs further purification. For example, the ethanol needs to be purified by distillation, etc. So it requires further purification. All right. Anyway, friends, I hope this helps, and best wishes and take care.